Hey everyone, hope you're all doing great. This is Abhishek Pradhan, and in this video we are going to learn how to design a counter. Okay, so before going any further in the detailed explanation of how to design a counter, let me just give you a small introduction of what a counter is. Well, a counter is a circuit which is used to count pulses, and apart from counting pulses, it is also used to measure frequency and time. Now, let the content of the video begin to how to design a counter. There are 5 steps which are needed to be followed to draw a binary counter. They are: first step is drawing the next state table. The second step would be drawing the excitation table. The third step is drawing the transition table. And the fourth step would be converting the data from the transition table into the KMap to obtain expressions. And the fifth and the final step would be drawing or implementing the circuit diagram for the counter. But before to that, it is really important for us to understand the truth table of the required flip-flop. This is because counters are designed with the collection of flip-flop. So in order to design a counter, we need to know the truth table for those flip-flops. Let us consider as an example. Now we are going to design mod 8 counter using T flip-flop. For drawing this, we need to know the truth table for the T flip-flop. And before moving, let's just analyze the question. They have given mod 8. So we need to draw a combination having value of 8. So for that, we need 3 signals, 3 input signals basically, and we'll have all the 8 combinations starting from 0, 0, 0 to 1, 1, 1. All the binary from 0 to 7. Okay, now let's get started. In a step 1, we are going to draw the next state table. The input for this next state table will be T, Q, and the output will be Q plus. Q is the present state, and Q plus is the next state. Now, for the inputs, we are going to draw all the 4 combinations starting from 0, 0, 0, 1, 1, 0, and 1, 1. The truth table for the next step of T flip-flop is for 0, 0, we have 0. For 0, 1, we have 1. For 1, 0, we have 1. And for 1, 1, we get 0. So, we have drawn our first state, next state table, which is of step 1. Moving on to step 2. Now, the excitation table. Well, in this table, we are just gonna rearrange Q and Q plus. Basically, what we are gonna do is, we are gonna consider Q and Q plus as our input and T as our output. So again, here we are gonna draw all the 4 combinations, 0, 0, 0, 1, 1, 0, and 1, 1. And in order to draw this T, we need to go back to our next state table. For these combinations, the corresponding T value, what we have in the next state, will be the same for the excitation table as well. For example, we are considering 0, 0 combination. For the combination of Q is equals to 0 and Q plus is equals to 0, the corresponding value of T is 0. So here comes 0. Now similarly, for 0, 1, 0, 1, T is equals to 1. For 1, 0, T again is equals to 1. And for 1, 1, T is equals to 0. So this finishes our step 2 of drawing the excitation table. Now moving on to step 3. In step 3, we are going to draw the transition table. In transition table, we are basically going to draw 3 main columns. first column would represent the present state. In the next column, we are going to draw the next state. And in the final column, we are going to draw inputs. Now, as I have told you, we are going to draw 8-bit counter. So, we are going to draw for all the 3 combinations, all the 8 combinations starting from 0, 0, 0 to 1, 1, 1. And for that, we need 3 variables or 3 bits. So, they are QC, QB and QA. So, drawing all our 8 combinations, we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. This would be 0, 1, 2, 3, 4, 5, 6, 7. And for our next state, we have the next state, that will be QC plus, QB plus and QA plus. And in the input section, we have TC, TB and TA. Now, how to draw the next state? Well, the next state will be the next corresponding state of the previous present state. For example, now we have 0, 0, 0. The next state of 0 is 1. So, the next state would be 0, 0, 1. It's simple. Similarly, for 0, 0, 1, the next state would be 2, 0, 1, 0. For 2, the next state would be 3, 0, 1, 1. For 3, the next step would be 4, 0, 1, 0, 0. For 4, the next step would be 5, 1, 0, 1. For 5, the next step would be 6, 1, 1, 0. For 6, the next step would be 7. And for 7, as we don't have any more combinations, so it's going to be a loop. So for 7, again we are going to go back to 0, 0, 0. For 7, it would be 0, 0, 0. The next step of 7 would be again 0, 0, 0. Now, how to draw TC, TB and TA values? In order to draw TC and TB, TA, we are going to go back to our excitation table. In our excitation table, we have these combinations, and corresponding to these combinations, we have our T value. So, similarly, for TC, we are going to see for QC and QC plus, the present state and the next state. So, as I have told you, Q is the present state and Q plus is the next state. So, for the variable C, when we are considering TC, we have Q, we are going to consider QC and QC plus. So, we are going to consider 0, 0. For 0, 0, we get 0. Again, for 0, 0, we get 0. For 0, 0, again 0. Now, we have 0, 1. As we have seen, for 0, 1, the value of T is 1. So, for 0, 1, the value of T is 1. And for 1, 0, for 1, 1, the value of T is 0. So, again 0, again 1, 1, 0, 1, 1, 0. Now, for 1, 0, the value of T is 1. Similarly, we are going to fill for TB and TA as well. Let's consider for TB, we need to consider QB and QB plus. 0, 0, we have 0, then we have 1, then we have 0, then we have 1, 0, 0 will give 0, then we have 0, 1, 1, then we have 0, then again 1. Now, for TA, we need to consider QA and QA plus. So, here the value will be 0, 1 gives 1, 1, 0 gives 1, 0, 1 again 1, 1, 1, 1, 1, 1. So, this finishes our transition table. Now, in step 4, what we are going to do is, we are going to analyze these input signals, that is TC, TB and TA, and convert them into expressions. And for doing that, we are going to use KMaps. So, moving on to step 4, KMap. Now, let's consider the KMap expression for TC. We all know how to draw a KMap. here we have QC, here we have QA, QB, and this will be 0, 1, which is QC and QC bar. So here the combination will be 0, 0, 0, 1, 1, 1, 1, 0. Now we need to fill, based on these corresponding values, we need to fill the values in the KMap. So as it is 0, 0, 0, the value goes here 0. As we can see, 0, 0, 1. So QC is equals to 0, QB is equals to 0, and QA is equals to 1. QC is equals to 0, QB is equals to 0, and QA is equals to 1. For this, we have value again to be as 0. So similar to that, based on the combinations, we are going to fill the KMap. This becomes 0, comes 1, comes 0, 0, 1, 0. So we are going to group the ones here in order to get the expression. So based corresponding to that, here value is QA is equals to 1 and QB is equals to 1. So our expression would be QA, QB. So our TC expression would be QA, QB. So we have got our first expression. Similarly, we are going to draw for TB as well. TB, again the same formula. Here comes QC, here comes QA, QB, here comes 0, here comes 1. The combination would be 0, 0, 0, 1, 1, 1, 1, 0. And based on the TB values, we are going to fill this KMap. This KMap gives the expression TB is equals to QA, as the only common we have in this expression, that is QB, QA and QC is 1 and 1 for QA. So this expression gives TB is equals to QA. Moving on to the KMap of TA. We have QC, QB, QA. One important thing that we need to keep in mind here is we need to go in sequence. As you can see, we have QC, QB and QA. Similarly, we need to go in a sequence: QC, QB, QA. So this values will be 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now filling the KMap, we get, as you can see, all the values of TA is 1. I can directly fill all the slots to be 1. Now when I have this, I can group all the ones. Now the expression would be for this would be TA is equals to 1, because I have filled all my boxes. So we have TA is equals to 1. So by the end of this, we have found out all the expressions for TC, which is equals to QB, QA, TB, which is equals to QA, and then TA, which is equals to 1. So we have found out all our expressions. Now moving on to a final step and the most important step, step 5, drawing the circuit diagram. For this we need our expressions, that is TC is equals to QB, QA, TB is equals to QA, and TA is equals to 1. So in order to draw this, we need to draw flip-flops. As we know, the counter is a combination of flip-flops. So as we have 3 expressions, we are going to draw 3 flip-flops. 1, 2, and 3. Let this be for A, B, and C. And based on that, we need to draw the corresponding value. The input would be TA, the output would be QA, and QA bar. This is not plus, this is bar. Next we have TB, QB, QB bar. We have TC, QC, and QC bar. Then one important thing, we need to have clock signals in flip-flop. Well, this is a synchronized flip-flop, so all the flip-flops will have a clock signal. So what you can do is, this will be clock. You can just extend this line here and here and here. So now all my flip-flops are connected to a clock signal. Now moving on to the expressions. We have TC is equals to QB and QA. So what I'm going to do is bring out this QA expression and QB value, and it, because it's a multiplication operation here, I'm using an AND gate for this, and I'm going to send the signal to QC. Simple. Then we have QB is equals to QA. TB is equals to QA. So what I'm going to do is extend this line. So I have a connection between QA and TB. So TB is equals to QA. Now my third expression is TA is equals to 1. So what I'm going to do is give a connection, and value of this connection is 1. So this is my QA, this is my QB. So this is the required diagram. This finishes our problem of designing a counter.